Hello guys. One of my students asked me to record a video lecture study guide, my CherNotes, on a pH scale. So CherNotes, I want to give a shout out to one of my tourist students who came up with this phrase, CherNote. My name is Cherno, and he said, Professor, why don't you use cool name CherNote? So I'm using it. Thank you very much, my student. Are you gonna get extra points in your class for exams? No, I'm not allowed to do that. But thank you very much. I'm gonna use those share notes. That's phrase. It's I hope it's catchy. All right, so let's get to the thing. Let me share my screen. Page scale. So he asked me. Oh, well, not him, but other students asked me to create a study guide on this. So you look at pH scale, right? So, and it's vertical. So I prefer to explain and I prefer to use a horizontal style. So let's look at the horizontal style pH and I hope it is going to be more comprehensive. So 7, as this 7 is neutral, 0 is on the left, and 14 is on the right. So 7 represents neutrality. So it's neutral pH. 0 represents low pH, right? I'm going to abbreviate low pH. I put a dot here. And 14 is going to be high pH, right? So where the confusion is when you look at this scale, right? Low pH pointing up and high pH pointing down. So to those who's new in this, right? It is kind of confusing. So I would rather use horizontal scale. However, when we say high acidity, that's understandable, right? It's pointing up. And when you say high alkalinity, it's still pointing down. So when you already know what the pH is and how to look at the scale, so it's going to be a lot easier for you to comprehend. Doesn't really matter what scale, the image of that scale you're looking at. So let's look at horizontal. And I usually in class explain the horizontal because you can say shift to the left, you into acidosis, and shift to the right, you will be in alkalosis. So let me use this color. I'm gonna follow with the color coding. So when you shift to the left, right, you are in acidosis, right? So your tissue could be acidic or your liquids, right? So acidosis. And when you shift, when the scale shifts to the right, I'm gonna use blue, you in alkalosis state. So now we can say low pH, right? Going from 7 towards 8. I'm sorry, going from 7 towards 0. So you're going down. And going from 7 to the right, you're going towards alkalosis. It is a high pH. So this is low pH and this is high pH. So also we have here 6, 5, 4, 3, 2, 1. 8, 9, 10, 11, 12, 13. So when you say that you are, or the person in, or your teacher in alkalosis, right? So it is high pH. If you're in acidosis, it is a low pH. So you can say high acidity. By saying high acidity, you're going down. By saying low acidity, right? By saying low acidity, you have to shift to the right because it is high acidic, but it's low pH, right? So let me use another color. So high acidity equals to low pH. I know it could be confusing, right? And then you can say low acidity. I'm going to put it here. Low acidity, right? By saying low acidity, meaning that you are shifting to the right, right? Low acidity shifting to the right. Um, it is a high pH. Even when I'm explaining, I really have to think thoroughly what I'm saying because that's where the confusion comes from. So when you have a horizontal scale, it is more comprehensive because low, you're looking here, right, at the scale, one is low, one is high, so that could be confusing. So low acidity, not low pH. By saying low pH, it's high acidity or acidosis. And low acidity, it is high pH. You're going from zero, you're going up, right? You are ascending instead of descending. So when it comes to alkalosis, that's the same thing, right? So high pH, it means that it's low acidity, right? Low pH, it means that it is you see, low pH, it means that you are in acidosis, high acidity. I have to stop for a second and I also have to think. So, all right, so this is the neutral pH for liquids, for tissue. Let's say the acidic state in your oral cavity because the bacteria is there, bacteria munching on carbohydrates, let's say, and producing toxins. So, and those toxins are acidic. So they create an acidic environment in your oral cavity. So, and from 7, your tissue drops from 7, it can get all the way to 5. And that's where the demineralization of your teeth of enamel starts. So saliva has a chemical called bicarbonate. Bicarbonate that neutralizes acidity. It's HCO3, right? So that's the bicarbonate. Another name for bicarbonate is buffer. Also in our blood, we have the same chemical, bicarbonate, that neutralizes acidity. We say neutralizes acidity, but it also neutralizes alkalinity, right? So it needs to bring your environment in which that bicarbonate is present into that neutral. So when we're referring to tissues or in your body, that's the neutral pH 7. But when we're talking about blood pH, right, neutral pH, so blood neutral pH range would be from 735 to 745. So when your blood pH, let's say, is 7.0, it is acidic, right? So you are in acidosis because neutral pH for blood is 735. So that's where the another confusion. So when you're reading a question during a test or you're reading something, pay attention to the context, right? So if we are talking about blood, so the neutral pH 735, 745, that's the range. And this bicarbonate molecule job is to make sure that you're not shifting all the way to the right or all the way to the left, because when you drop to 7, it is acidosis. So if you get to the 6.8, it's very dangerous. If you shift to the right and go into alkalosis, right, and you get somewhere to 8.23, it is very dangerous. So this bicarbonate molecule is present in both, in the tissues, right, in the saliva, not in tissues, in the saliva produces, and it also in blood. So, and another last thing that I want to talk about, so the difference and how acidic the certain foods, right? We're going to go into acidosis, right? From 6 to 7, it is a tenfold. So let's say number 6 is milk and saliva. So milk and saliva 10 times more acidic than distilled water, than water. So the difference between 6 and 5 also tenfold. But what is the difference between 5 and 7? So 10 multiplied by 10 is 100, right? So coffee is 100 times more acidic than water. Then again, if we go by another 10, 10 multiplied by 100, 4 would be 1,000. So tomato juice is 1,000 more acidic than water. Then we go by another 10, 1,000 multiplied by 10 is 10, I mean by 100 would be 10,000. So number 3 is apple juice. Apple juice is 10 times 10, right, 10,000 times more acidic than water. And then you multiply by 10, that is 100, then you multiply by 10. So it's pretty easy to get to the million, right? So I'm not going to multiply by 10 by 10, but then you get the idea. So it's a tenfold. So every time you have to multiply by 10. So that's basically what it is. So when we say low pH, it means that it's high acidity, it's acidosis. When we say high pH, it is a high alkalinity, but it is a low acidosis. So that's where the confusion is. That's why I prefer to use horizontal scale over that vertical scale, because I also seen vertical scale that 0 was not only here, 0 was here, and 14 was here. So whoever come up with that, please explain me. Maybe there is a reason to that, right? Please explain me. Please comment under that video, and please explain to me. Maybe you've seen some other explanation, but I would rather prefer horizontal one. It's easier to explain. All right, guys. So I hope that that was comprehensive. All right. So have a great day.